It started recording. Welcome to today's talk. We'll be talking about open source and probably touch upon a few other stuff as well. Uh, Probably something related to object-oriented programming. But let's see. Let's start with open source, and we'll start with our experiences on how we got started with open source. So yeah, Mrigank, you want to go first?
Sure, man, sure. Okay, so let's start with the shift in open source software development. Uh, recently we have seen a lot of trend where people are making good stuff by collaborating on open source platforms. So, for example, like your VS Code is a great example of a open source product. Even though it's sponsored by Microsoft, like people from all over the different kinds of industries are contributing to it to make it the perfect thing that everyone will like be useful for everyone else. And so like if it should we like talk about how to get started with open source first, or you want to add to it?
Uh, yeah, yeah. Kanishka, go on.
I, no, I was saying I think we should do this towards the end, like this in sense, like what we think. I mean, what you're getting it right? Like, does open source work and things like that? I think we should do it towards the end. Let's start with like how to contribute. I guess that's what
Okay,
most
okay.
people are interested in. Like, I mean,
Sure,
most of
sure.
the juniors will be most helpful.
Yeah. Okay, we'll do that. So I'll just give a brief overview of the whole process, and we can see. Okay, so so open source is built upon communities and how and collaboration and stuff like that. So basically, how you get started with open source is uh, the most popular platform for open source projects is GitHub, as you may know, or you may not know, but now you know, uh, is github.com. There are a lot of projects hosted on github.com. So basically, you can go there, and of course, it's an overwhelming amount of projects, but you could narrow it down based on what you like or what languages you know. So, for example, the first open source project that I got involved with was called MPS YouTube. So, MPS YouTube was a, is a tool which you can use to watch YouTube videos in your terminal. And as the naive first year I was really interested in like doing everything inside the terminal and being cool and stuff like that. So MPS YouTube is a tool which allows you to do that. And uh, I started using it, and it was a really cool tool, but it had a few problems that I wanted to fix, or it was missing a few features that I needed. So I looked at the project. It's an open source project, and it was written in Python, and I knew a bit of Python. So I started contributing to that project. I started fixing a really small bug, or there were a lot of open issues. There is an issues tab in GitHub. I went there. I looked through the easy issues which I could understand, and I started contributing the fixes. So this is the first important point. You have to contribute to the project if you want to get started. Like however small your fix may be, you have to do it. Like the first step is the most important one. And what I observed after I started contributing to it was that I gained a better understanding of how the code is structured and how the
Saying he was king.
Yeah. It, so we can add him, right? Or he can join via the link, right? Anyways. Mrigank, you'll continue. Like you can start. Maybe we'll when Vishnu gets back, he'll talk about his bit.
Here, he's back.
Yeah, I'm not sure what happened. I got kicked out of the call for some reason. So did you guys hear anything I was saying, or was everything lost?
Yeah, we could hear till issues, I think you're talking about.
Okay, so let me pick up from there. So the most important thing is that you have to look through the issues, and however small the problem may be, you have to fix it. So yeah, once I started fixing the issues, I gained a better understanding of the code structure and how the different modules interact with each other. So this is the real important thing. This is the second important thing. You are reading other people's code. This is a really hard thing to do. Reading other people's code is, and reading and understanding it and changing it is a really hard thing to do. It's not easy. And I don't think there is an easy way to do that. Uh, at least it comes from the experience. So basically, you have to start contributing to get that. It's a kind of loop. Like you have to have experience to contribute, but you have to contribute to have that experience. So it's stuff like that. Anyway, moving on. Uh, so that's the next thing. And after I started, I solved like a couple of small issues. Uh, I got a better understanding of the core pieces, and I could make bigger changes. So I started to add a completely new feature to MPS YouTube, and it took me like I think probably 1 or 2 months to complete because I didn't know a lot of Python back then. This was my first project, and it's a big project. So and there was just one maintainer. He was usually busy, so he won't respond to everything I had, every question I had. And the only way of communication was through GitHub issues. There was no other method of communication. So it was a really slow process, but I was getting a lot of fun from that. Like it was really cool to contribute code to a project which is used by probably thousands of people, and my code was actually making an impact. So it was really fun for me, and I badgered on and um, um, yeah, I badged on and I got my pull request merged. It took me like 2 or 3 months. A few months after that, a new organization was formed of MPS YouTube, and I go because I had taken up such a huge project. Like I did all this work, so I got an invitation to join the organization as well. So I think these are like the good things that come out of open source. You get to be a part of a big thing, which like a bigger than you, in fact, and your code is going to be used by other people, and it's going to have an impact on other people. So yeah, I think I was a bit clear on the approach. So I know it all sounds vague, like the basic idea is just contribute, but I think that's the only secret sauce there is. There is no secret sauce. Basically, you have to start contributing, and you have to do that to be good at open source. As far as projects are concerned, some projects are really unresponsive. Even if you want to try to contribute to that, I don't think you'll get the opportunity. So basically, you have to do some work. You have to research on the project, whether there is a lot of activity on the project, whether the maintainer is helpful. Usually, open source maintainers are usually helpful, but you still have to do a bit of research on your own. And I think the way I contributed in the first year to this project really helped me get the GSOC selection in the first year. Like I did not know a lot of Python when I joined college, and in the first 6 months, I think this thing contributing to MPS YouTube helped me gain experience which cannot be bought. Like it's not like you will get this experience for free or anything. And Yeah, I think that was my introduction to open source, and if I think it might help someone else. So Miten was asking. So back to a question. Miten was asking: is contributing to open source more helpful than creating a new one? So there's both sides of the story. You can create a new one. Creating a new one is much easier than contributing to an existing project. You have the full creative control if you're creating a new one. You don't have to be you basically can follow your own design and you can make your own decisions. When you're contributing to another project, you are basically contributing to someone else's project, and they have the final call. They make the call whether your code should be accepted or your code should be rejected. If your not code is up to the quality, they may reject it. But I think that is actually a good thing, because your the quality of your code will improve immensely, because most projects won't accept shit code, and you'll need to rethink. Like, if you look at the professional environment, I don't have a lot of experience, but I think that it's collaborative. You basically have to look at other people's code, read other people's code, work with other people's code. So this needs an empathy that open source can give you, because you're basically contributing to someone else's project, and you're trying to align your thoughts with him over just some comments which are on some issues. So I think this is what you gain through contributing to a new project, like an existing project, is really valuable. But of course, creating a new one is interesting as well. I have a kind of a popular existing a project which I created. It's really fun to create a new one, but the maintaining part comes in when you're creating a new one. If you don't want to maintain and you're just ignoring it, it's fine too. But if you want to maintain a open source project, it's really hard. Like, it takes a lot of time, and it's harder than writing code, in my opinion. So I think that answers that, Miten. So Kanishka, do you want to add something to this?
Um, yeah, so in personal, like what I've heard from others is that like generally contributing to some other project, like you have, see, first is, yeah, there's this experience, like what you talked about, like your code review and your collaborative effort that improves. Like, see, they're like, so it's a simple thing. Like, we end up using a lot of hacky design patterns. Like, we end up writing code that works, that does the job, but is not actually good, and it'll actually kick us back sometime later. So, I mean, such things are pointed out generally when you're contributing to an open source project. But if it's your own project, you end up like going ahead with it anyways, because it's your own project. And second, and I think an important thing is recognition. Like, so unless your project kicks off really well, your open source your open source projects don't matter that much. So like, you're getting it right. Like, if I end up contributing to some big recognized organization, even if it's even if it's not that big a contribution, it still has some kind of like value associated with it. So that's one thing. So generally, generally people so it's like, yeah, it's like the value associated with your contribution. So that increases when you contribute to some other project. And I also feel that you learn a lot more that when you work with some other project. Like, so there are things that you might not even think that you would work on, but you might like, there might be like, let's say, domains or some kind of technologies that you might not work on if you had been doing it all by yourself. But if you were, like, let's say, contributing to some open source project, and let's say you became a part of their community, then you might end up like exploring some interesting things. So I think that's there, and I think that's all I have.
Yeah, if you're like an absolute beginner, I would suggest like contributing to an existing project would be a better idea, so that you get understanding of how the software are like designed. So now, once after you have a basic understanding, and like if you solve a problem using your own open source project, and people start to like it, like Vishnu's project, so that people even more people more experienced than you will come together and collaborate. You maybe they'll make things better than you had created. So it would be, eventually you will learn more in the process.
Yeah, totally. I want to go off a tangent on that design part. I think a lot of people ignore the design part. Like, it's really mind blowing that how many programmers don't think how their I don't. I say programmers. I mean students. Don't think how their code is structured and whether they might need to change it down the line. I think it's a really important thing to think about whether you like basically designing your code so that it is easier to refactor or it is easier to extend or adapt to a new situation. I don't think enough people give attention to that. Do you guys think the same?
Yeah, exactly. Like if I'm making a project of my own, I'll only care about like things work. I usually, if I was a beginner, I wouldn't care about the extensibility and maintainability of the project. That's something you learn from a mature project.
Yeah, but I was hoping that we could rant on how you know uh, design patterns are ignored. But sure, I think the open source part is kind of done now. Like the getting started in open source part. I think it was Harsh who asked that. I think he's satisfied. If not, you can probably put that in the chat. Yeah. So should we? Yeah.
Yeah,
Kanishkar, go on.
I have, yeah, one small thing. So like, yeah, one thing I'd suggest is try to go for small ones. They're easier. And also, I mean, if you, so like Vishnu pointed out about how communities are not active. And there's another thing about how some communities are not really interested in getting new developers. So it's like they have an open source project, but it's like they have a team of 5 6 people are working on it and they don't want to really spend time onboarding someone else with the project and stuff. So you might, I mean, in such projects you might end up wasting a lot of time. Like you might end up like actually maybe let's say you might end up making PRs and you might not be getting reviews on time, or people might, I mean, stuff like that can happen. So I think you should you should look into that. I don't know how would you figure that out, but that happens. So if you're not like, yeah, so there are chances that you might not get your PRs reviewed, or things might get ignored also. And yet also one thing I figured, I mean, I think it works is like try to figure out like startups which are pushing hard on their open source projects. I don't know if it makes sense. So there are startups which are like going in a partially open source manner, where they have an open source product and they are offering an enterprise version of it. So this always happens in cloud native space. Like any cloud infra related projects has like it has this. So now the thing with this is, now because they are startups, they need people to work on their projects, so they tend to be like very active and very, what do you call it, first welcoming, and they're very welcoming, and they help you get onboarded with the project quickly. Because I mean, it's simple, they're a startup, so they don't have a lot of money. So I mean, if they're trying to go with open source, they try to get as many contributors as possible, so that I mean, first is that your project gets recognition, second, your work gets done. So I think that's a good way to go. And this happens a lot in cloud native space. So if you, I mean, look out for projects which are there. There are a lot of, I mean, if you try to figure out who, like, you can do the simple thing. Just look at the contributors to the project and see where they work. If you see most of them belong to a company which is not that well known, it is a startup which is trying to build a cloud native product and is offering it as an enterprise version. And those people are generally welcoming. I mean, it's just something I noticed. You can, I mean, I don't know if it'll help.
In the community space, I want to add that Mozilla is really good with their community. Like they're one of the most welcoming communities. They even welcome you to fix the issues on the Rust compiler. So if you really want a community which will handhold you, I think Mozilla is a good project. Like projects under Mozilla umbrella is probably a good place to start, but it's usually much more complicated than your normal projects. but I believe there are easier ones. You can contribute to that. I have not researched a lot on that though. Yeah, so I guess open source is done. We can move on to maybe object-oriented programming stuff, rant on how object-oriented programming is bad or something. What do you guys think?
Kunal, any any inputs on this?
I mean, it's not that bad.
Yeah, I've heard this from people who like have work experience. That's the thing. That's the most interesting part. Like, I mean, I've heard from other two, a few other people. They say that oops is not that bad. I mean, it's not actually not that bad. They say it's actually good. And there are some, like how Jain pointed out, there are some use cases where oops fits the best. So, I mean, I'm not really sure.
Yes, it helps a lot in your code maintainability.
Yeah, but okay, like so how I saw this. I think
But
this is
people abuse it a lot as well.
yeah.
I've seen some code personally where oops is abused. I mean, a hell lot because they used factories for only a single object, which was never to be for a single class, which was never to be ever maintained. So it was a hell of factories that I had to go through, like 3 levels deep of just factories that I had to traverse to get to the actual code.
I think Java is like number one contributor
Yeah.
to this problem. Like literally, like the amount of abstractions that Java gives make you want to write bad code. Like I don't even understand some of the uh, like for example setters. Like if you have a value, uh, if you want to expose a value, basically write a getter and setter for that. I don't really agree with that. If you are doing no validation and no other kind of stuff, and you are still in a compiled language, even you are still writing getters and setters, I don't really think that is a good paradigm. You are just adding another level of indirection. And
That's for the future, don't you think? Like in the future, maybe you'll add validation, so you'll have to change it everywhere if there are no patterns, right?
but that's what IDEs are for. If you want to change it, you basically write or use existing tools. You don't write I don't know, getters and setters everywhere. I
Yeah,
think.
looking at them is not a very good thing. Writing them is not a big deal. IntelliJ does that for you automatically. Or sometimes people even use Lombok. I personally hate Lombok.
Lombok is
Uh,
pure magic. Like I don't.
yeah,
Yeah.
inject
What does it
dependency
do?
injection. So you can just add an annotation over your existing classes to add getters and setters. You
So
don't
basically,
have to
it's
write them manually.
yeah, it's compile time code generation. So you can add the Lombok the at Lombok to any class, and Lombok will generate the getters and setters for you at compile time. So basically, if you import that class, you have an automatic getter and setter, which you have not written. This is the most confusing thing I think there is. Like you're generating compile time code which is invisible to you, but Java things. Yeah. Also, I would be really interested to see how the new languages like Rust or Go will be used to write, object-oriented code. But because like inheritance is one of the biggest thing that is abused. Given that Go and Rust does not give you the inheritance model, I would be really interested to see how it's gonna play out with code written in Go or Rust.
I believe it's also got to do a lot with the guy who is writing the code. It's sometimes the kind of mindset that people have when writing the code that they always write it in a specific way. They people try to pre-optimize. They think, okay, this can be extended in the future and think like that for everything. They also have to look at it logically sometimes. It's always good to have your code maintainable, extendable, but sometimes if it's not a use case in any way, then just don't do it.
Yeah,
It's always
agreed,
good to think about the design first, then write code.
agreed.
Yeah, so regarding Go, I personally think they didn't go object oriented because I think Go was mainly meant for writing backend services, I feel. Like so if you're writing backend services, you don't need really object oriented. You need, I mean, it doesn't, I mean, I don't know. I don't think it makes sense. Object oriented and backend service, like if it's specifically backend services, then object oriented is not required. I think that's the reason. I mean, that's why Go, I don't think that's the reason, but I think that's why it works well with Go, like not having OOPs.
But Go 2 is actually borrowing some of the OOP ideas, basically generics, and yeah, just generics. They already have something like interfaces. Okay, they have interfaces, which is basically an OOP idea. But I think it's the inheritance part which really bugs me, because like I have really seen that, like almost all code, like if, like for example, like as a simple example, if you look at the GUI toolkits, like those are nowadays those are purely object oriented stuff. Like if you look at GTK or Qt, uh, when you see it at first, it's really interesting because like you have a widget, and every single widget you have is basically a subclass of the that superclass called widget, and you can pass these widget around and stuff like that. But when you want to optimize it, or when you want to like it like what I've seen is that it hides a lot of stuff which, if you really want to go to the lowest level to optimize stuff, it really makes it hard. So I think it's a so if you're building abstractions for someone to make it easy for them to write code, I think OOP may work. But if you're really working in a constrained area where performance is the single most priority, I think OOP actually breaks down. Or that's what I got from a lot of talks that I saw, and I kind of agree with that as well.
It's weird because HFTs use OOP. It's a general thing. Like HFTs use C++, that means they use OOPs, and they cannot have. I don't think it's like that though. That if you use OOPs, it'll break down. I mean, I don't know. I think it also depends on the way it is designed. If it is designed properly, I think it. I mean, OOPs can give a lot of advantages. I don't know.
So one thing I'd like to talk, like maybe Aditya Jain can like clear this up for me. So basically, if you're writing an abstract, purely abstract base class in C++, you will have virtual methods which are to be overridden by subclasses. This like immediately adds a level of indirection when you are when you're employing code, any code that uses it. Basically, if you're calling a function, there is a vtable cross reference. This means you're going to the memory, you're going to the memory which points to the vtable and accessing the function pointer and calling it. This is, I don't know, this feels crazy to me. Like if you're serious about performance, you're basically like, if you look at the what do you say, the latency for a memory access, it's like 200 times more than 200 cycles approximately.
Yes,
So
yes. If you want performance, you don't do it. That's the thing.
so they
Virtual, yeah,
okay,
virtual functions, everything. It's bad for performance, and where you want performance, you just don't do it. You try not to do it.
okay, so yeah, okay, that clears up for me. That clears that up for me. Yeah.
Yeah, there was a stock, right? I think it's by one of the guys from HFTs in which he says you use templates. Try to use templates instead of
Yeah,
what, right?
yeah. Templates instead of this thing, and it was a really
Yeah,
interesting talk. Even. Yeah.
yeah. I also okay. I just want to know: is functional code always fast? I mean, I'll tell you this. So Jane Street, in one of their interns, they made them write a network driver, a user space network driver in OCaml. And then I read that how Jane Street uses OCaml a lot in their stack. And Jane Street is yeah, it's also an HFT, and I think OCaml is like pure functional. So I think there's no question of doing anything like anything. I mean, I don't think it supports anything oops. So like any opinions on that? Like, I mean, if they're going to use OCaml for everything, that means it has to be fast, or at least to some extent. And if that, I also feel functional is faster for some reason. But Kunal, Jain, anyone, any pointers on
OCaml is
this?
multi-paradigm. I've seen some OCaml. It is
Oh, it is not.
multi-paradigm. It's not
Oh, it's not pure
only
functional.
functional. No.
Oh, okay.
From what I know, Jane Street is they extensively market themselves as that they use functional programming a lot, and if you are interested in all that, so they are definitely using it as a functional programming language. But I don't know how they're using it. From my limited experience, I feel that it would be considerably hard to do it, but they are somehow doing it. So I don't know.
Also, for performance, isn't the uh, like whether it's compiled or not would be a greater factor than the paradigm used, right? Because like in the end, you're all compiling down to assembly, and assembly is the fastest thing that you can write. Like if you're writing handwritten assembly, it will be the fastest, and that's basically what do you say, like top whatever that is, like it's just it executes instructions one by one, so it's not a functional or paradigm or anything. So I don't think the paradigm matters much. You could probably write performance code in both paradigms.
Yes, totally. The paradigm shouldn't matter. Uh, as long as you have ease of coding and you are able to write code which generates good assembly, then it should be fine. And if something is compiled, then obviously you have better ways to optimize it. So the fact that something is compiled is more important than whether it is functional programming or if it is object oriented or anything else. So you are totally correct here. And then the next thing is that, is assembly the fastest thing we can do? No. You can definitely do faster things than that. You can Assembly works on a particular what should I say? Yeah, so we have processors which have a particular design, and assembly is written to execute on that. But if you are capable, you can develop your hardware, which, as you know, we learn in IIT in Anirban Sir's class, how to use FPGAs and all those things. So you can write RTL for that and have your custom hardware, which can do stuff for you much faster than how your uh, very what should I say, strict and rigid processor would work on.
Oh, that is interesting. Yeah.
If you are sure you want to do something, if it's really critical, then you can use your own hardware. That's the best thing you can do. It's faster than assembly because the processor doesn't know what you want to do. It's a general purpose thing. But when you have your own circuit, then you know what exactly you want to do, so you can make it work the best for that case. So that's why the industry is using a lot of hardware. They need a lot of hardware developers, designers for that, and these
Mhm.
are the things we learn even at IIT Indore. So it's a really cool thing to know about.
I read about, okay, so I think that's why we have this concept of hardware accelerators, like where let's say you have some kind of I mean, some kind of code that runs in a particular pattern. And let's say you have like, I think what, how I understand hardware accelerators is like, if you have some kind of code that runs in a particular pattern, then you can have specific hardware which runs those things. And I think that's becoming like I think it is. I think it will catch trend. Like I don't know why. I've read about how AMD is adding co-processors. Like with your CPU, it's adding other processors which will do other specific computations, so that it'll get faster. So I think that will be one way which will. So that'll be one thing which will boost performance.
Yeah. Yes, this is very much happening, and it is actually the industry is actually much more excited about this than we think it is. So these things are actually growing at a very fast pace, and a lot of hardware developing companies, and in fact, even the main ones like Intel and AMD, they are very much interested in providing custom hardware to solve math problems and to do a lot of things, to do a lot of scientific computation calculations, solving differential equations and those kind of things. So once you have custom hardware, it is really, really fast. And if you have custom hardware like this, you also save a lot of time, which is spent in getting your stuff into the software and doing some processing. You can do a lot there down itself.
So will these hardware improvements trickle down to the consumer hardware as well? What do you think?
Yes, I do think so. AMD is doing it with their Ryzen. I know it. They're having co-processors, which I don't know what they are doing, but I know they're doing. I saw this
Okay.
video in which it was there. You can check it out. You can just check out co-processors in Ryzen. I think that should give you the details of it.
Yeah, sure. Yeah. So yeah, where did we get this tangent from? What were we talking about? I think compiled
We were
languages.
t- we were talking about whether something being compiled is
Yeah, yeah,
matters or the paradigm matters, and then I said we can do faster than assembly.
yeah.
Yeah, we are there.
Yeah, that's a long way. So yeah, compiled languages. So yeah, anything more to add in that space?
Uh,
Actually, quite yeah.
no, I just want to ask, like, so in cases of languages which do JIT or just-in-time compile, so in that case, can it get faster than what? Oh, so let's say we remove the garbage collection. I'm talking specifically of JVM. So if we remove the garbage collection, let's say, or somehow we have something for the garbage collection, but we do just-in-time compile, can it get faster than what you would? Because I mean, I've read that sometimes it does get faster. So
It can get as fast as the thing, I guess. But the faster part comes in. I think it's more nuanced than that. It's usually in micro benchmarks. So micro benchmarks usually don't tell the whole what do you say, the whole image. So I recently saw a benchmark, a micro benchmark where something written in Go was faster than something written in Rust. So you'll think like, so Go is not an interpreted language, nor it's it a JIT compiled language. It's a purely compiled language, but it does not do a lot of optimization. So that's how that's one of the factors why the compilation speed is really fast, and it also has a GC. It's a GC language, while Rust is not. So I think like what I'm speculating here is that, I mean, I did not look into the micro benchmark I am talking about, but what I'm speculating here is like goes like if it's a short running process, if it's like finishing in 10 or 20 seconds, Ghost GC will cheat. Like it will just like basically allocate a buffer pool and just give out memory from that space. The GC essentially does not have to run anytime. Like it does not have to free any memory. It will basically just give out memory so that the code is really fast. You could essentially do this in Rust as well, or any other compiled language. You could basically create your own buffer pool and hand stuff out. But because the compiled Rust code actually does the allocation and deallocation and the bookkeeping that's required for dynamic memory, that could be why it's slow. So like a blanket statement like, okay, JIT compiled languages can be faster than compiled languages, I think, at least at some cases, I think it's a really skewed perspective, and whoever wrote that is probably trying to push something. But of course, I'll need to see the code and things to comment further or properly analyze it. Uh, as far as JIT compiled code is concerned, it can get as fast as compiled code, I think, because like it's basically down to the compiler, like the bytecode to machine code generation it has. And I don't know whether like we are not seeing any more JIT compiled languages anymore, because I think it's a 2000s thing where the processors were in fast, like it's like a hack basically. Like they wanted to trim down on the compile speed, so they thought, okay, let's do this. I mean, I'm not sure. Like I am talking with my really small experience with this, but yeah, it kind of feels like that.
I believe JVM can reach speeds of up to C or maybe C++. I think the way JVM has evolved over the years, it has added a lot of optimizations in itself. The as you called out JIT, and also you can do some bytecode optimization as well before running. Uh, ProGuard is generally used for that, and I think there is some performance tuning that JVM does it in itself. Uh, like it can, you know, deop code that has been JIT and stuff like that, and then fall back to the previous path.
What exactly? Deop code? What were you? Can you clear that up, Kunal?
So, JVM, some JVM machines can, I believe, de-optimize code that was formerly, that was JITed before, and you
Oh,
can
okay.
actually, uh, and it can go back as well. So that
Hmm.
if you want, it allows some, aggressive performance sometimes in between.
Hmm. I see.
So
But I
if
don't
you
think.
actually look for performance in JVM, some people might even tell you that okay, the startup is kind of slow, but as you run your code and as it works, uh, you know the speed becomes faster. The
Yeah.
whole thing becomes faster.
Yeah, but I think it can only get as fast as C, or as fast as hand-tuned C. In my opinion, like I don't think it can actually get any faster than hand-optimized C.
I think the runtime optimizations can do more. I mean, see, you're getting it right. Like, so C would do all compile time optimizations, but I think JVM has that advantage where it can observe runtime parameters. Like, let's say you're not using something, it can throw it off and things like that to make your code faster, which C can not do. So I think in some specific cases, JVM might do that. Kunal, any opinions on
Yeah,
this?
sometimes even pointer handling is not that uh, good
Yeah,
in C. Uh, and abstracting that away might help because the JVM may do things behind the scenes that you may not know or which you cannot perform at runtime.
yeah, that's true.
I would like to add something to this. So, as Kanishkar pointed out, that maybe JVM could have an advantage of having runtime knowledge, but at the same time, when C is getting compiled, it knows all of the code. So at compile time, C has a lot of advantage that it knows the global state of the program. So overall, during compilation, the number of optimizations that can be done are much more than if you compile a small chunk of code during when you execute. And secondly, there are a lot of optimizations which you do not at compile time, but say at link time and that. So I'm not sure if those kind of optimizations can be performed in a JIT compiled language. I don't know the benchmarks or anything, so maybe I'm totally wrong. But yeah, I have this opinion that still there is a big chance that compiled languages in most cases beat JIT compiled languages.
Yeah, in
Yeah,
most cases, that's true. So it's that
Yeah.
thing. Yeah. So it's like that JIT does provide optimization. So what you'll end up having is spikes. Like you might. So it's like you have C code. Like let's say you have the same software written in C and Java maybe, and you're running it, you'll most probably see C, like let's say you'll see C showing more consistent performance while JVM would be like randomly doing stuff. Like you might see sometimes some things get faster than the C, but I mean, because it's random, you can't really say anything. So yeah, on a general note, like 90% plus, I would say 99% maybe it's a compiled time language would do better, but yeah.
Yeah, I think even in the 0.01% where JIT may actually perform better, you could probably look at the behavior of your program, because like your program will follow a pattern. You could probably optimize it, but yeah. Uh, by the way, an interesting thing that I saw in a talk by a guy from Google. So one of the things that he showed was like basically C++ has an ABI, has a stable ABI which it won't break. So like what he was showing was that because it has this ABI, it cannot do some optimizations that could be performed, and thus it was incurring some cost. This is in C++ area with the smart pointers and stuff like unique pointer and shared pointer. It's not like basically if you're writing handwritten C, that's not the case. But yeah, in C++, so you may incur some hidden cost if you end up using some of the newer paradigms.
Yes, that is correct. So I don't remember where I read this, but I think there have been discussions in the standards and the committees that if we are keeping a particular ABI, there are a lot of things we are not able to include. So that's a real point of discussion, and you're correct. Because of that, a lot of maybe cool optimizations they're not able to do it.
Interestingly enough, Rust does not have a stable ABI. You can export C ABIs, but it does not have a standard ABI. So there goes, yay Rust. It's almost a meme nowadays. Yay Rust. Let's rewrite everything in Rust. Yeah. Yeah. Anything more? Interesting how this actually turned into a conversation on languages. Like we started from open source to object oriented, and we ended up in languages. Like we are always gravitating towards languages. Like last talk was basically about languages. This one ended up being on compiled and interpreted languages, I guess.
Well, it is the programming club.
I guess so. But it's yeah. We have web to talk about. We could talk about web stuff.
Yeah, let's keep it next time, maybe. Arjun, you might, I mean, so we were talking about hardware acceleration and stuff. Want to add something to it? I mean, it would have been better if you were there that time. So I end up having a lot of conversations with Arjun on it. So that's why I thought I'll ask him.
I don't know क्या discuss हो क्या, so I'm not sure.
So first, yeah. So Jain pointed out how I mean assembly is not the fastest thing. You can write FPGAs, and I mean you can use FPGAs and end up having custom hardware to get faster. And then like we talked about hardware acceleration or co-processors to get like some specific computing things faster. So I think that's what we talked about.
Acha, nice. I missed all of that. Did you talk about learned indexes and all that?
No.
Acha, so there's also I heard the last wala part about JITs and compiled languages. So I agree with everything that the compiler has more knowledge about the structure of the program, but so unless the runtime is complicated enough, what a lot of interpreted languages can also do is exploit the structure in the data. So which is that we're now seeing it happen in some places. There's a really nice paper called "The Case for Learned Indexes," I think, in which they basically learn uh, a bet. Imagine you want to sort hundreds of arrays, and the arrays have some structure in them. So what you can do is, instead of doing a quick sort, just where you always take the middle pivot, you could actually learn which pivot to select. Does that make sense?
Yeah.
So it's basically learning as the program, how the program evolved.
Yeah.
And okay,
So
interesting.
even though semantically the output does not change, you can go much faster by exploiting the structure of the data that you're fed in. But again, Joe, the thing you talked about, about fixed latencies, all those issues still crop up. Like if you do all of this, you won't get a consistent output cut time. There'll be jitter all over the place.
By the way, just wanted to point out that compiled languages can have runtimes. So it's not like only JIT languages have runtimes.
Yeah, exactly. Yeah.
There are tons of compiled languages which have runtimes. So
Like, I mean, could you explain? I mean, just explain this more.
yeah, Go has a runtime basically. Like the coroutines, the coroutines are basically green threads. There is a
Okay.
the whole memory handling is done by a runtime. So
Yeah,
and
BMVM, Elixir, Erlang, and all of those too.
yeah, those two.
Wait, okay. Erlang was, yeah, Erlang is not even compiled, right? It is like almost, I think it's JIT, right? Or interpreted.
I mean, it gets kind of messy when you go into runtime
Okay.
plus compiled language, या फिर interpreted language.
Yeah, the whole like I think I had like a really heated argument with someone on Reddit on what makes a compiled language and what makes a VM interpreted language and stuff like that. It was crazy. Like the whole definition on the around this is kind of blurry.
Yeah.
And there is this language called VLang. Man, there is like a full-blown controversy on that. And one of the controversy, like the one of the starting point of the controversy was like, how do you define runtime? Like what essentially is a runtime? So there is this language called Odin, and the creator of Odin project was saying that basically runtime is any runtime libraries. If you're using STD, like the libc, libc is essentially a runtime. Like the name of libc is libc runtime library. So basically, libc is runtime. So like the terminology is all blurry. But like if you're taking runtime as something which manages stuff for you, there is like still tons of languages. Like yeah, basically, I think Go is like the most pronounced example for it.
Yeah. So Abhinav pointed out that C++ is getting coroutines. Did any of you?
What?
So yeah.
Yeah, C++ is not getting, it has gotten coroutines in C++ 20.
Yeah.
But I went through the implementation. It's actually quite complicated to actually make use of them. But I think with time it will improve.
Coroutines as in green threads, right?
I think so, Jain.
What's a green thread? What's a green
Uh,
thread?
Basically, runtime schedules and manages the threads. You can make tons of it, and like it's not like a system thread. Like you don't get a one-to-one mapping, you get a M2N mapping.
No. Not like that. It's basically like at one point of time, only a single thing is executing in. I mean, at one point of time, you are at a single point in the program, but you can suspend the execution there. Let's say you are inside some function, you can suspend the execution there. Your stack gets saved, and then you are back to the function which called it, and then you can execute some more, and then you
Oh,
can resume execution back in the stack. It comes back,
Ah,
then you do stuff
like
like that.
generators.
Yeah, generators, exactly. Generators is one thing.
Yeah, cool.
So,
Oh, so this must be like the building block for async and from there on.
Yes, yes, yes,
yeah.
yes.
So is it something like they all the coroutines share a same stack, or right? I think is that so, or do they have different
Um,
stack?
no, there is only one stack, but when you
Yeah.
suspend, so
Yeah.
they do a lot of allocation on the heap for some stuff, and when you suspend, they save particular stuff on the heap, and then they clear out the stack, do some stuff. It's something like that. So it's mostly um, the internal stuff, how things work. It's not changed. It's just that they have made ways to uh, save some context on the heap and get it back.
Yeah, that's interesting. Yeah, it looks like async. I mean, yeah, it looks very similar to async.
Yeah.
Yes, yes.
So is it like okay? Yeah, never mind. I think I got it. Quite interesting. C++ is getting a lot of stuff. First it was RAII, such a bad name, but still.
RAI has been there from a long, long time.
Yeah, 11, right?
No, no, no. This concept has been there uh, from I think 20 plus years.
Oh
In
yeah,
11, yeah.
yeah.
I
They
think
formalized it.
in terms of smart pointers, we kind of got these things into mainstream and maybe
Yeah.
created some things. Yeah, but the idea has been there. And if you see the class implementations and you have member variables and all that, they follow RAII from
Mm,
from
yeah,
whenever they first came in.
yeah.
For C++ coroutines, I wanted to mention that I think if you're interested, you should definitely check it out. And even I don't know much about it. I tried last week how they work, and I think it was really tricky to get them to work. If you are, it's basically like you have to implement a lot of things, lot of boilerplate code to make things work. And but still, the good thing is that some people have already built up some libraries on top of it, so I think it wouldn't be that bad. But it's still in a very, very initial stage, but you should definitely check it out.
So is it meant to be used by other libraries to, write a syntactical sugar on top so that you can easily use it? Uh, Stuff like
Yes,
that,
yes,
maybe?
someone will have to do it, and I think there are libraries already which in which people have done it. Otherwise,
Oh,
uh, in terms of C++, what they have actually done is provide the internal mechanism and provide a few keywords such as co-yield, co-return, and co-await, these three. And then basically you have to implement a promise type class, which when you suspend, this class will tell what to do. When you yield something, this class will tell what to yield. And when you resume execution, this class will tell how to resume. So basically you have to write everything.
oh, this is really similar to the Rust implementation. Like,
Exactly. I was about to say Tokyo, right? Like this is how it was.
yeah, exactly.
Okay.
Yeah. Yeah. So, but I
Weird.
think I think Tokyo has been here for 2 years. So I think one of the problem with this was it was like you pointed out, how hard is it to get started with it? So I think then they ended up having abstractions over it, right? Like which make it kind of easier, if not very much easier.
I think the Rust async world is like in a lot of churn right now. I think that's one
Yeah.
of the biggest problems with Rust. Like there is a lot of churn. Whatever you may end up writing today might look very different 1 year from now. So I think that is probably the problem with async right now. But yeah, like probably 6 months or 1 year down the line, I think the whole ecosystem will stabilize. So I don't think it's necessarily to do with Rust or like Tokyo or any other executors. So yeah, it's really confusing anyway. The whole async in Rust. I I'd like to check out how C++ does it, because if it's if it's actually considerably easier in C++, it really has something to sell there. By the way, does anyone actually use Rust in like large scale HFTs and companies like that? Do you know anything, Aditya Jain?
No, I don't know.
Do you guys talk about Rust?
I can't say.
Oh, sure. Yeah.
There's a thread in Reddit on it. You can just open the R Rust and search for HFTs. So I think someone in Tokyo uses it. But yeah, you can just check it out. There's a
Oh,
thread on it. Yeah.
that's great.
Yeah, but it's not used a
I'll
lot. Like people
definitely do that.
prefer to have the control. Like I think C and C++ have that advantage where you can do whatever you want until you know what you're doing. So people in HFTs especially, they prefer to have that control, like to squeeze the last down, I mean, performance they can get. So maybe that's why I don't think Rust will ever get into HFTs. So yeah. But anyways, it's just
Yeah.
an assumption.
Yeah. This probably could be said for anything that's not like specifically user facing. So I think a lot of people who are not like basically not writing code which is like security first would probably choose C++. Again, completely an assumption, but yeah. I guess that's it. Our 1 hour mark is here. Uh, so let's wrap up. Nothing more, right? Yeah, I guess that's it. I'll stop recording.